Hello everybody, this is my exercise 5 presentation. We will be covering clustering and segmentation, and I am on team 3. My name is Nathan Kotas. My group is Sophie, Savannah, Freddie, and Mark. And with that, we can get right into the presentation. So the first slide that I'll be covering is hierarchical clustering. And so the first question is, what are some of the shortcomings of the hierarchical clustering? And they are known not to scale large data, and also especially with a large number of clusters. And then the second question was to briefly explain the main ideas underlying how Perch clusters data. And so the first thing we decided was designed to scale to a large number of points and clusters, purity enhancing rotations for cluster hierarchies, consumes data points one at a time and incrementally builds hierarchical clustering, and then also data points arrive, then it routes to nearest neighbor stored in a leaf. If the program discovers that it is not similar to the leaf it currently is on, and then it rotates to fit better. The data point is added to bounding boxes and they are adjusted to how similar the node is to others. And we can continue to the second slide. So k-means clustering. So what are k-means clustering algorithm main ideas? We thought the main ideas were k is the number of clusters you wish to identify. It measures the distance between data points and the 3 initial clusters. It also assigns the data points to the nearest cluster. It adds the variation within each cluster, and then finally it calculates the mean of each cluster and then forms new clusters based on the means, then repeats until the clusters no longer change. So the second question for k-means is, what are some shortcomings of k-means clustering? And we thought some of those included trouble clustering when the clusters vary in size and density, and then also outliers can easily skew clusters. So we'll keep it moving. So the Moneyball slide includes, after carefully considering an analysis of all options, we decided that it is best to go with 5 clusters and only 4 bins. So 9 clusters seemed too many. The graphs weren't very clear and clusters were similar, so that wasn't a good option. And then less bins made the clusters look more separated and clear and easier to draw. So that's what we decided to go with. And this is the first one. This is group 1. It includes field goals made, free throws made, 3-pointers made, and points. And so with this, you can see in the 3-pointers made, there's some different clusters there. The field goals made, it's really skewed more to the right with, you can see the orange were bigger, the orange groups were bigger, and then same thing with free throws made, the orange is really the largest group there. And then the next one we did, group 2, was field goal percentages, or percents, which included field goal percentages, free throw percentages, and 3-point percentages. And you can see some of the images here. I won't go through all of them, but really you can see how some of it begins to get busy, which is why we decided to go with less bins. And then the final group, group 3, we did blocks, turnovers, steals, rebounds, and offensive rebounds. And you can see some of the different clustering here. Really, purple is the largest cluster that is or in the graph is the largest. And so that is what we came up with here. And that is the end of my exercise 5 presentation. I hope you enjoyed my presentation and look forward to what we can get going next. Thank you.